Добрый день, уважаемые гости. Рада приветствовать вас, международный.
Dear guests, good afternoon. It's my pleasure to welcome all of you to International Press Center РИА Новости. Tonight we have Professor of Berlin Free University, a remarkable celebrity in neuroeconomics, Mr. Hauke Heekeren. And today we are going to talk about neurobiology and our decision-making process. In a couple of minutes, I will leave you alone with the lecturer, and I'm sure you'll enjoy the dialogue between yourselves and himself on what is neurobiology, on what emotional motives mean in decision-making, and of course, our dear guest is going to talk about Neuroeconomics in terms of fundamental decision-making models. So, dear guests, please take your seat, relax, and start your lecture. So, Mr. Hauke Heekeren will be all evening tonight, and you can ask your questions either in the course of lecture or after it. Thank you.
Perfect. Yeah, thank you so much for this, what sounded like a very kind introduction, although I did not understand a single word, but maybe two words, my own name. But thank you all for coming out, and I would like to first thank my hosts here. So first of all, Vasily, who is leading the Russian graduate program in neurobiology and neurotechnology, a terrific initiative, and I think you need much more of that here in Russia. And I'd also like to welcome the students of the Neuroeconomics course that is just about to begin here in Moscow. I think it's a terrific initiative, and I'm sure that we're going to see much more of this. And I would also like to thank the organizers of this lecture, so the new economics school here in Moscow, and of course the news agency RINA for hosting this lecture. So thank you all for making this happen. It's a great pleasure to be here in this very wonderful city with this terrific history. I'm of course not speaking Russian, I'm going to give this lecture in English. I tend to speak rather fast, so if you don't understand what I'm saying, just give me a sign. Try to slow down, and of course you're very welcome to pose questions anytime. Okay, just make a little sign, and I will try to answer your question as we go along. Just start the timer. Okay, so now, what am I going to talk today about is how we make decisions. And obviously, this has long been a topic for economists, also for philosophers, right? So there is a lot of, some centuries work on decision-making in philosophy, quite a long history of work in economics. And, but the thing is, the economic models and economic theories of decision-making never really cared about what was going on inside our heads, so in the brains. So the way we process information was something that economists did not care about. And most of them, up to this date, still don't care about it. And I hope that we're going to make that change. And I'm going to try to show you some examples of how we can use new methods from neuroscience and neurotechnology and psychology to inform our thinking about how we actually make decisions. And I hope at the end that you're going to be convinced that this is a worthwhile endeavor, and that really this neuroscientific approach should be part of the agenda for economics. So, to make sure that we all know what we're talking about, to give you a very fundamental, very basic definition of decision-making, you can think about what we do, all of us, as human beings, and similar to animals, actually, who go through the world. We perceive a lot of sensory input. Yeah, so basically, that's what you do, right? You live. So you see, you have input through your eyes, you have input through your ears, you feel touch, and your way to interact with the world is obviously through motor output. So basically by doing things. You do things with your hands, or also by speaking, by producing language. It's also a motor action. And to give you a very basic definition of decision processing, it's pretty much anything between the sensory processing and the motor output. So anything that happens in between, you could think about as decision processing. Yeah, this is very fundamental and very basic. Now, when it comes to actually more decision making in the sense of economic decision making, you could take this as a very simple example. So an economic choice. So you have two goods, so two different kinds of candies. So this would be the candy in the form of a boiled egg, basically, something you may have for breakfast, but as a candy. And this is supposed to be little dolphins. So another sort of candy, right? And so basically, a very simple choice, two similar goods, so both are candies. And now the question is, how do we make those kinds of choices? And what can we learn about this using neuroscience methods? As it turns out, one of the key factors that has an impact on how we make decisions is the value of these goods, right? So basically, your expectation about the result of your choice, right? So basically, you have certain expectations when you think about this thing here, these little boiled eggs candy, and opposed to that, you may have some expectations about the pleasure you may get from eating those little guys. And the idea behind a very simple model is that this difference in value that you assign to them will determine your choice. And this is something, this would be a very simple choice. And so this would be the case for what we would call a primary reinforcer. Yeah, things like food or water, liquids, or sex. So very basic things that matter to any human being, right? Would be primary reinforcers. So you know you're going to get a certain feeling of sweetness, a certain pleasure from the calories that you can take in by consuming it. And of course, these choices can get more complicated. So they could involve things that don't have a direct value, that don't translate into calories or something like that. And money would actually be an example for that. So this is what we would call a secondary reinforcer. So it obviously, our organism doesn't, basically money it doesn't have a value for any organism, right? I mean, you can't eat it, you can't burn it into calories, you don't get pleasure from consuming money. But the point is, money allows you to buy things from which you derive pleasure. So basically, thereby, it's a secondary reinforcer. And obviously, economists deal quite a bit with money. So we have to clarify a couple of basic concepts when we discuss simple choices. And obviously, the value that you assign to objects that you make decisions about depends a lot on your current status, so on your current wealth, let's say, if you deal with money, right? So the example here is, and this is an old concept introduced by a Swiss mathematician, Daniel Bernoulli, maybe like in the middle of the 18th century, I think. And so he figured out that obviously, if I give you $10, or a bunch of rubles, the utility, so the value that you personally take from it depends on how much you have to begin with. So basically, if you are a poor student who doesn't have anything, you have $0, I give you $10, you get, it's very useful for you. So you assign a high value to it. It has high utility for you. That's the concept, utility. In contrast, if you have more, let's say you're a better off student, you already have $90, I give you an additional 10, you don't value them that much. Okay, so that is what Bernoulli back then termed expected utility. And there are related concepts now, something like experienced utility, so the value that you personally derive from consuming a certain product, or also from expecting to consume it. So that's the concept of utility. And so one of the, I would say, let me take one step back. So we are now using neuroscientific techniques to observe human brains in action while they actually make choices. And those of you who have followed, who tend to follow scientific literature in, let's say, psychology or other domains, more often than not, neuroimaging hasn't really produced anything new, right? So it usually told us that, okay, if we put you into an MRI machine, so a scanner that you would also find in a hospital, some of you may have been in this, you can measure how the blood supply to a certain brain area changes. And this has been invented in the early 90s, and we have seen a couple of thousand studies since then that have used this to observe the human brain in action. And what other scientists often complain about is, well, you guys with your fancy brain imaging techniques, you never tell us anything new, right? So there are many studies that would show you that this part in the back of the brain gets more activated when you look at things, yeah? Or you see activity in the motor cortex when you do things. So that is nothing fundamentally new. But in this case of looking at humans making actual choices in the magnet, we and others have discovered fundamentally new things. So for example, you can find this region here in the brain. So this is at the forefront of the brain, right here in the so-called orbital frontal cortex. So it's basically at the front of your brain, right above your eye sockets. And this brain region tends to show activity that corresponds to the value that you assign to an object. Yeah, so this was actually something we did not know beforehand. Yeah, so this is the prime example, I would say, where we needed the influence of economics, so with the context of utility, of assigning value, and concepts from psychology, together with neurotechnology, to actually discover new things. And I'm going to show you examples how we can use this now to look at more complicated questions as well. But I want you to keep in mind that there is this region here, the ventromedial prefrontal cortex, part of the orbitofrontal cortex, and also another structure furthermore in the center of the brain, the nucleus accumbens, or also ventral striatum. And these two brain structures have very consistently, across many studies now, been shown to respond with value that you assign to an object when you make a choice about them, or when you expect to consume something, or when you have actually consumed it. Yeah, so let's say I'm telling you, in a couple of seconds, I'm going to give you a little bit of sweet liquid. These structures are going to light up, and also when I give it to you, they're going to respond. And the value, the activity there corresponds to the value that you assign to it. And this has been, just to give you two examples really, this has been shown very consistently using all sorts of different stimuli. Yeah, so you can do this with candies. You can do it with wine in the magnet, which is, if you think about it, somewhat odd, right? You're lying flat in a very dark machine. You get wine through a little plastic tube, drip-wise, and sometimes it gets rinsed or something else. Some different way of tasting wine, really. But still, despite these really hostile environments, you still get these responses here in those two brain regions, the orbitofrontal cortex and the ventral striatum over here, that fires or shows changes in activity corresponding to the value that you assign to it, either wine or candies. And of course, as I hinted at already, also with money, right, with secondary reinforcers and with all sorts of other things. Now, let's come to a different concept. And I would like you to now study these two wheels of fortune. Basically look at them. And I would like to ask you, the audience here, to decide which of the two wheels you would like to spin. So let's imagine, you paid, I don't know, €3, and you now, or 1,000 rubles, and you now get the choice to either play this wheel of fortune, and so basically you spin the wheel, and wherever it stops will be your reward for that event, or you decide to spin this wheel, and where the wheel stops will be your reward. So maybe. Okay, let's do this in an orderly fashion. I'm first going to ask for the left wheel. Who would like to spin the left wheel? Okay, and who would like to spin the right wheel? It's almost 50-50, maybe 50-50. So would one of you who chose to spin the right wheel tell me why? No? Who wants to? Yeah.
Just use the microphone, please.
The right one, because the chances that I get 20,000 in the end are pretty high, 75%.
Okay, yeah, that's
approximately.
right. Yeah.
That's
And
it.
you're not so afraid of it ending on the 4.
I take the risk.
You take the risk. There you go. Okay. And maybe somebody who chose the wheel on the left. Would you tell me why you wanted to spin the wheel on the left?
I would like to change the left one because it is riskless.
Yeah. Okay.
Yes.
Yeah.
I always win.
Yeah, good. Very. You always win. Okay, good for you. You would always win in this case, exactly. So there you go, right? So those two explanations were perfect. So what this example really shows is, so one other concept is the expected value. So you could compute it by multiplying the probability of an event with the actual reward. And what you see here is, as one of the guests just said, in like 75% of the cases you end up with $9,000, and in a quarter of the cases, 25%, you even end up with more, 10,000. So if you add this up, this boils down to something like an expected value of $9,250. So that's fine, and it's pretty safe. In this case, in contrast, the average you get, so the expected value, is actually much higher, right? So it's 75% of 20,000 plus a little bit. So in the end, this boils down to, what was that, 16,000 something. So it's actually much higher. But as these guys just pointed out, this one is much, much riskier, right? Because you have a 25% chance of virtually winning nothing. Well, $4, but basically nothing. And so that's the other very important concept, the risk, that is the uncertainty that is associated with certain events. And the perceived risk. So so economists would just compute it. Psychologists would basically ask people, how risky do you think it is? Both measures tend to be quite close to one another. But the point is, the actual value that you give to something will be the potential value minus the risk. And then how much you weigh it, as we just saw, differs a lot between people. Right? And so some seek the risk, they say, I like the risk, I'm not afraid of this. The others say, no, I want the safe thing. So that's the other important concept that determines economic choices. And as you may imagine, we now have also a lot of evidence that we can pinpoint that there are certain brain regions that show activity that corresponds to the risk of a situation. So, and also to the perceived risk. There are quite a few brain regions, but it turns out that there's one that seems to be really important for it, and this is the anterior insula. And that also makes a lot of sense for biological reasons. So this is a brain region that kind of monitors the events in the body. So it's kind of a way to monitor how well you're doing. And if this region is very much activated, it kind of signals you to induce avoidance behavior. So basically it tries to bring you to action to get out of a situation that is potentially dangerous, to put a somewhat complicated story rather short. But the point is, this is true across a number of studies using completely different situations. So it's fairly safe to say we do have a brain system has been identified where activity also correlates with the riskiness of a choice. And now I'd like to give you a couple of examples how we may use this in neuroscientific research on how this may also help to understand economic decision making. So let's assume you're about to go on a cross-Atlantic flight. There may be some babies on board, so you may actually want to have these nice noise-canceling headphones. They are on sale at the airport for $299. a steal, a real steal. So now you have to, if we had to design an experiment, we would probably offer these headphones to you at different prices, and then would ask you whether you would actually want to buy them at that price or not. And that's the kind of experiment that people actually do. Yeah. So maybe not always with these high prices. You could also do it with candy bars, for instance, with things that cost less. But in those experiments, people have to actually purchase the items. So this is not just hypothetical, right? So basically, if you say in that experiment, yeah, we give you money in advance, of course, before the experiment, and you then decide how to spend it. And this would be one example. Now, another way to think about this is that this is also a decision that is not just about the value that you assign to it, but it's also about the cost, right? So ultimately, you have to pay $299. So basically, it's a trade-off between the additional utility you get from having the headphones and the cost in terms of losing the $299. And we can use that then in a neuroscientific experiment. I would also like to use this example to illustrate another aspect about this. And this is, I think, this is the kind of stuff that fundamentally changes also maybe economists' thinking. So to give you a cartoon illustration of the way we currently think about how these kinds of decisions are made. You could think that there is something that we call a decision value, and this decision value tends to fluctuate over time, so it changes. And this depends on the new information that is coming into the system. And this can also be information within the brain, basically a result of information processing. And once this signal reaches one of the boundaries, it leads to either to accept this response, so you would say, yes, I'm going to do it, I'm going to buy it, or if it reaches the other boundary in a certain time, this leads to a reject response. So basically you're going to say, no, I'm not going to buy it. And the point here is that what this means is that we take the neural information. This is meant in the very literal sense. So you have regions in the brain that listen to the brain systems, the neurons, that fire for the potential gain, so of getting the headphones, and you have other neurons that fire because they want to keep you away from doing it. So they kind of fire corresponding to the potential loss. And this process is noisy. So the neurons, the firing of the neurons, the activity is noisy. So it's not all or none, right? And if you integrate that over time, it's still a noisy process, which may, from time to time, lead to an error. So you can imagine if this is very noisy, so basically this fluctuates a lot, you may sometimes by chance hit this boundary before you're really ready to make the decision. But you're still going to make it, and it results in an error. So this is one explanation, this model, this so-called drift diffusion model, is one way to account for errors in simple economic choices. Yeah, and this is, the errors are usually the problem that economists have with their theories, right? So they know a lot about how things should really be done, so the normative side, but very rarely they say a lot about the mechanisms. And this is one way of currently thinking about this. And I hope this is going to be clearer once I now introduce the neuroscience to go with this. So how do we do this in the lab? So what we told subjects is, our participants, they first learned that different colors would correspond to winning some amount of money, and that the shapes of the colors would correspond to losing a certain amount of money. And then, after learning this for some time, all we asked subjects to do is to decide whether they would actually want to to take this item or to buy it, if you wish. And let's say, so this could maybe correspond to, on the one hand, yellow may say, well, you win something between 80 and 100 cents. And the square may tell you, well, you're going to lose something 60 to 80 cents. So what you have to do now is you have to make this cost-benefit integration to come to your decision. Yeah, so it has the aspect that you can get a measure of the value assigned to the object and at the same time of the potential loss associated with the object. And what we can now do is, and this follows from what I told you before, we can identify the brain system that fires corresponding to the gain. So this is from the actual experiment, why subjects make those choices. And at the same time, we can look at those brain regions, like here in the amygdala, where the activity corresponds to the potential loss. And we can now check how these different things are traded off with each other when subjects actually make those choices. And what we then find is, so this is literally asking in which brain regions is this activity that corresponds to the gain and this activity that corresponds to the potential loss traded off against each other to actually tell you something about the resulting value. And not too surprisingly, we get exactly the same area of the ventromedial prefrontal cortex over here, right over the eye sockets, that I talked about in the beginning. Right? So this is the region that we and others think represents the value of a choice you're making. And this is, so we take this as evidence that actually what happens here in the ventromedial prefrontal cortex is that you're weighing off the different attributes of a potential choice against each other. And this has a further angle to it, so then this, and then you have other brain regions, like here in the parietal cortex, that seem to listen to this region that represents the value and ultimately lead to this decision. So they basically listen to the activity here. Over time, this can be somewhat noisy, but once you reach the boundary, you're going to say, yes, I want this, or no, I don't want this. So again, first evidence that what I described here is literally a mechanism, a biological mechanism underlying economic choice. And I think this is something, and the experience is that this is something where also economists now start to listen. Yeah, because they also think, yes, indeed, this may be something where neuroscience informs economic thinking. Because we can maybe then use this information in actual economic models and to also predict individuals' behavior. Yeah, I summarized this first part right here. So what's new? What are the news that come out of neuroscience that may be interesting for economics? So first of all, the brain computes this decision value signal at the time of choice. This is when you consider different options. Second, it computes an experience utility signal at the time of consumption. So this is when you actually receive the output of your decision. And finally, as a third step, that these choices are then made by comparing these decision values using what's called a diffusion model. And the next question then is, how can we now use these tools from neuroscience, right, where we can learn something about how the value is represented, what happens to the risk, and how the two are traded off against each other? How can we use these tools to understand some of the phenomena that have puzzled economists? So classic examples for things that economists would call irrational behavior. Right, because it does not fit with the standard economic theory. And here's the first example. So let's say, this is going to be a little experiment with you guys again. So the question is, so these are two faces, two regular guys that you may meet in a bar in Moscow. Well, they probably wouldn't be called Tom and Jerry, but maybe yes, maybe they're tourists. And now your task is to tell me which of these two faces do you think is more attractive. So we're not arguing about hairstyle, right? It's the same, but just tell me which one is more. So who thinks Tom is more attractive? Show your hand. Okay, that's relatively few people. Who thinks that Jerry is more attractive than Tom? Okay, and the rest doesn't care. Okay, you don't think they're attractive at all. Okay, so you think more people think that Jerry is more attractive than Tom. Okay, now let's add a third guy, right? So this is Jerry's somewhat less attractive, maybe less attractive brother. Yeah. So this is the third guy, maybe his twin brother. So let's do this experiment again. You tell me again which of these three guys now do you think is the most attractive? So who thinks that Tom is most attractive? That's maybe fewer people than just before. Who thinks that Jerry, Jerry's twin brother, is most attractive? Come on, Vasily. Okay, and who thinks that Jerry is most attractive? Those are maybe a few people more. Okay, it's kind of a messy version to do this experiment because you would, of course, have to show it to different groups. But what usually happens is if we did this experiment properly, and we could of course do the same thing with Tom, right? There happens to be another version of Tom, so his lost twin brother. He's what? Okay. Okay, and now what would usually happen is this. So if I just ask you, as I just did, do you find Tom or Jerry more attractive? You make a certain choice. Yeah. So in your case, more people found Jerry more attractive. So let's say it was 40% for Tom and 60% for Jerry. And now, if I now add the third guy, this most people would agree that he's slightly uglier than the original Jerry. And what then happens is that even more people than before find Jerry more attractive. Yeah? So adding this slightly less attractive version of Jerry leads to a little shift in the number of choices for Jerry. And now this is something that economic theory can deal with, because the economists say that your what's called the preference, so your decision whether you would rather like Jerry over Tom, should not be affected by adding something that's clearly a worse option, right? So this Jerry is definitely not more attractive than the original Jerry, so it should not have an influence on your preferences. It should not affect your choice between Tom and Jerry. But it does, yeah, it does. And it also does if we turn it around. So doing it properly with a number of different groups, if we now do the same with a slightly uglier version of Tom, this guy, this will have the effect that more people would say, I want Tom, than in the absence of this guy. So just choosing between Tom and Jerry. So I stole this from Dan Ariely. I think it's a great example of how the addition of an irrelevant choice option leads to a change in the preferences. And now let's ask the question, can we use neuroscientific methods to get an idea of why this is the case? Now, we're not going to do this whole thing. Now you can do the same thing with gambles, right? So I could ask you which of these three gambles you would prefer. Yeah, so it's either the option of winning 80 euros with 20% probability, or, so it's just a lottery, right? Let's say you paid, what would be reasonable, you paid me 5 euros to play this game, and you can either, which would be very advantageous for you, you can either win 80 euros with 20% probability, 20 euros with 70% probability, or 20 euros with 60% probability. What everybody here should realize is that clearly this should be an irrelevant choice option, right? So if you can decide for winning 20 euros with 70%, you should not pick this one. Okay. We can translate the question. Can you translate? Okay, yeah. Yeah. Why is the sum? Oh, it's okay. It's simply it's not complementary. So it's basically you choose. It's three different lotteries. Does that make more sense? Yeah. Okay. Good. So now this will be the similar setup then as we used before. basically, just to clarify the terminology, so this would be our target, so winning the 20 euro with 70% probability. The competitor, which is also attractive, right? 20% with 20% probability to win 80 euro. But very clearly, this third option is what we call the decoy, right? So it's like as if this were Tom, Jerry, and the uglier version of Jerry, right? So this is just a worse option than this one. And you would wonder, why would anybody choose it? Same story. Adding this third option to the choice set should not affect your preference, the preference you have between these two options. Okay? But you know what's coming, right? If I now show you what people in Berlin do, if we show people in Berlin, university students obviously, the two-set option, on the order of 2/3 go for the target option. So again, this one. If we show them 3 sets with a third option that is clearly worse than everything we've seen, they don't change their behavior. But if we use this decoy as the third option, as I just showed you, more people than before choose the target option than before. Yeah. So again, this is like more people choose Jerry when the uglier version of Jerry is present. And again, this establishes that also, it's irrational behavior. Your choice should not be affected by adding this irrelevant option. So this is again just behavior, but it's nice to see that this also works with lotteries. And now we can do the same thing in the brain scanner to see what this is due to, right? So you could think that this is either due to subjects thinking differently about the risk associated with these different options, or they could value the options differently, right? So we don't know this, and economic theory is basically silent to this. So we can now use the tools I just described before to you. So we can look at the brain regions representing risk, and we can look at those brain regions representing the value of these options, why people are making these choices. And the summary result is that if we now compare the conditions, the events, where you have the 3 sets with the decoy, so with this uglier version of Tom in the mix, and we compare that to the situations where the decoy is not part of the choice set, then we get this pattern of activations. So pretty much looking similar to the brain regions that respond to risk. Yeah, and basically our interpretation of this is that the presence of this third option changes the perception of the risk associated with the competitor. Yeah, so in this case, again, the competitor would be this guy. Yeah, so just having these 2 options around makes you think that probably the second one is slightly less risky than without having the third option. So again, an example of how we may use the neurotechnology to get an idea about why people behave so strange sometimes when they make economic choices. Let me come to another example. This is a very classical example used by Danny Kahneman and Amos Tversky. In the meantime, Tversky died, but Kahneman actually received the Nobel Prize for this kind of research in 2002. And the example is this. So how do you halt the spread of a fatal disease? So I'm going to do this again with you guys. So you suppose you're a physician and you're trying to halt the spread of a fatal disease with one of 2 vaccines. Yeah, let's say in a faraway Russian province, there's this outbreak of this new fatal disease, and you now have 2 options. You're the Secretary of Health, and you have to make this decision. So you can either use what's called vaccine A. There's a lot of studies that you can rely on, and you know that this vaccine will save 200 of the 600 villagers. Yeah. and you're certain, there's no doubt about this, if you use this vaccine, you will save 200 of those 600. Not more, not less. 200 of the 600. Your other option is vaccine B. It's a vaccine that has not been tested so far. Yeah, it's untested. But you know from the reports so far that it has a 33% chance of saving all 600 and a 67% chance of saving none. Yeah, so again, 33% of saving all 600 and 67% chance of saving none. Now I'm asking you to make this choice. So who of you would choose option A? And who would choose option B? Okay, just let's see. So it's more people. Can I have A again? Vaccine A? Okay, it's at least a few. Let's see how this works. Okay, now let's use a different scenario to other therapeutic options for the disease, right? So same scenario. It's a deadly disease. 600 people in the village. Treatment C is a known treatment, great number of studies, and it will definitely kill 67% of the villagers. And treatment D is an untested vaccine that has a 33% chance of killing nobody, killing none, and a 67% of killing them all. So who chooses C? That's very few people. And who chooses treatment D? Okay, and there are quite a few undecided people. D? Okay, good. But the most important thing is that I think you already saw there was a slight switch in the preferences, right? And probably most of you realized that the two really correspond, right? So A, vaccine A, corresponds to C, right? It's just the other side of the coin, right? So it's basically safe. It will save 200, and here it doesn't say it will kill 400. It will save 200. Oops. And vaccine C is the same thing, just put with a negative spin. And the same for B and D, right? So this is the one where the chance is phrased as something positive, so you have a chance of saving a certain number. And this is again the opposite. And the main observation that comes from this, I don't have the actual numbers, but you basically, the trend we saw here using this messy group design was pretty similar to what you would find in the classic literature. Let me just see whether I have the numbers. No, I don't. But that's what happens all the time, right? So basically, if you put things into a positive frame, and that's the word, the framing effect, so the way you display the information, more people will go with this. Basically, the preference changes depending on the frame. So if I express the possible choice as something positive, you're going to behave differently from when I put it into a negative frame, which is, again, irrational, right? Because we're dealing with the same facts. It's just words. Whether I say, well, it's you may save 200 or 400, or it will kill 400 for sure. And again, irrational behavior. And now let's see whether we can shed some light onto that. Yeah, maybe the background to that. So one explanation, a psychological explanation that has also entered economics, is depicted here. So what this shows you is the relation between the objective value and the subjective value. And the point here is if you start from 0 and you experience a gain of a certain magnitude, it leads to this improvement in utility. And in contrast, when you have the same magnitude of the loss, it leads to much more disutility than the gain. So the point is, we are actually much more afraid, basically losing something is even worse for us than than gaining the same thing. Yeah. So I guess you can relate to that easily. Yeah, let's skip that one. And now, so we can now basically, again, use this kind of framing effect and also investigate it using psychological or also neuroscientific instruments. So what Benedetto De Martino and colleagues did already a couple of years back is they used this framing idea from Kahneman and Tversky and put it into a lottery task. And the simple trick is this. You first tell the subject you receive 50 euro, so it's kind of like an, or pounds in this case, doesn't matter, so an endowment, right? The experimenter gives you money, here are your 50 pounds, and then you have the following two options. You can either keep 20 pounds for sure, or you can gamble. And this gamble says, so you play the lottery, you're going to lose all with the probability of 1/3, or you're going to keep all with a probability of 2/3. Yeah, and you will realize once again, now you can do the same thing in what's called a loss frame, right? So again, you receive the 50 pounds, same thing as above, and now I tell you, you have two different options. One is to lose 30 pounds for sure, or to gamble. And the gamble, again, 1/3 probability to keep all, or 2/3 probability to lose all. So all that differs is the way you display this information, right? So it's a matter of fact, it's the same thing, right? Of the 50, you get to keep 20 and lose 30. So it's simply the same fact. You have the same money in the end if you make either choice. But just changing this bit of information changes the gambling behavior of the subjects quite a bit. So what this shows, and I'm just going to explain it because you can barely see it. So this says, this is the frame you're in. So this is the gain frame. So the one that says you keep, what was it, 20? You keep 20 for sure. And this is the loss frame. You lose 30 for sure. And what happens is that in the gain frame, people only gamble in about 40-something% of the trials, whereas in the loss frame, people gamble much more, right? So in the loss frame, when you tell them you're going to lose 30 for sure or play the lottery, in more than 2/3 of the time, people are going to play the lottery. Yeah. So again, dramatic framing effect. This is just behavior again. Another thing I'd like to point out with this example is, and this is something that's also, I think, where neuroscience and basically neuroeconomics is going to have a huge impact on economics, is if you look at economics, very broadly speaking, they very rarely look at the individual and especially at the differences between individuals. Yeah, I mean, we all know that people are different. Yeah, but economists most of the time tend to ignore that. And this is again showing this quite dramatically. So you have, this shows for each subject how much more they gamble in the loss frame than in the gain frame. And the numbers don't really matter. What this should show you is that there are quite a few people that show, a little effect. It's not dramatic. It's a little bit. It's consistent. All of them gamble a little bit more. But then there is this other half of the subjects that gambles a lot more. Right, and this is basically going back to the example we had in the beginning. Some people are more risk-seeking than others, and in this case, same thing, right? Some people are more risk-seeking, and some people hate losses more than others. So for some people, if you mention the possibility of losing something, they're gonna gamble, yeah. And other people think, no, I don't really care. I have what I have. I'm not gonna gamble. So this is one great example of how much individual differences matter. But let's come back to the framing effect. So of course we can now also do this inside a brain scanner. And what De Martino et al. Found again was that the activity changes in the amygdala, so one of the structures that's been closely linked to processing emotions, but also many other things, but that basically the pattern of activity there closely corresponded to this framing effect. And we can now basically use the same approach to also look at other factors that may influence this kind of framing effect. So what we did back in Berlin, we asked younger and older subjects to do exactly the same thing. Because what we know from many medical studies and also very recent neurobiological studies is that in particular the brain systems that deal with processing reward, so also value, and the brain systems that deal with processing risks change with aging. Yeah, and some of the changes are actually quite prominent. So that alone led to the question whether also the gambling behavior or the behavior in this kind of framing study is also different between age groups. So age as another important example for individual differences. And what this figure shows you is on the left-hand side more or less the same thing as in the study I just talked about. Yeah, so this is looking at the gain frame. Same story. If we told subjects that they are going to gain something for sure, do they want to gamble? They want to gamble more when we put this in a loss frame. You're for sure going to lose 30 pounds and you can gamble to win a little bit more. They gamble more. And this difference was even bigger in our sample of older subjects. So this is now taking people that are a group of people around 70 years old. And you can see that in the gain frame, so when we tell them you're going to win 20 pounds for sure, they tend to gamble about as much as the younger subjects, but in the loss frame, they gamble even more. Yeah, so that's an interesting difference. This is again looking at the individual differences now within the groups, and this just illustrates what I showed you for the British sample as well. So there are quite interesting differences between subjects already within the younger subjects. Not as pronounced as in the British sample, but these differences are even bigger in the older participants. And this is something that we also find with many other things. Yeah, so individual differences tend to get more and greater with advancing age. And we can then, of course, also use this again to relate it back to brain structures. And we found the similar thing, that in the amygdala, we find that the activity correlates with the susceptibility, so how much people actually respond to this framing effect. I'm going to skip this. So basically, those examples that I showed you now, in addition to the first things we started with, were meant to show you that we can use these neuroscientific techniques to better understand what economists consider irrational decision-making. And I also showed you some examples for the importance of considering individual differences. And before I come to the end, I would like to use a couple of minutes to introduce another thing that where I think the neuroeconomic approach has already yielded very important findings and will continue to do so. And this is the importance of social influences on human decision making. And it turns out that this again is something that's you can relatively easily do it with humans. It tends to be really difficult with animals. So this is actually one thing I think where neuroeconomics has already made important contributions and will continue to do so. So here's one example. Actually, an example I took from Vasily Klucharov's work here back in 2009, and this one deals with conformity. Just as one example. And to briefly summarize what subjects were asked to do, so again, people were asked to rate the attractiveness of faces that were more or less attractive. And then after providing their own rating, they would be shown the rating that another group, maybe a group that was similar to them, made about this face. Yeah. And you can see here, in this case, the subject said this is a 6 out of 8, not too bad, quite attractive. But the group in this experiment at least said 8, so it's 8 out of 10. So this is a very attractive face. And then after the scanner experiment, subjects were asked to do this again. And now Vasily showed those faces again, and people made those ratings again. And now you can see that the same person who did this experiment changed their judgment from a 6 to a 7. And basically, this is a very nice measure of conformity, social conformity, right? So basically, after you've seen the group rating, you're changing your own rating. And basically, how much you change your own rating in response to seeing the group rating is a nice measure of conformity. And to just summarize this very, very briefly, so this is just the group results. You can see that people adjust their behavior, their ratings, according to the group behavior. And one thing I would like to point out, also in Vasily's study, the ventral striatum, so the region that I talked about that responds to rewarding information and processing reward information and value, is again also has an important role in this social conformity processing. And there are other examples that go into a similar direction. So this is from related work by a Japanese group, Kaisi Izuma, and what they looked for is whether you could actually whether the reward system that I showed you in the beginning that processes things like candies, liquids, money, whether this would also respond to social rewards. And in this case, social information was conveyed by adjectives that a group, made on you as a person. So if you would be a participant in this study, you would see adjectives that people found would describe you, right? So you could see a picture of yourself, and then the adjective, let's say, trustworthy, or modest, or just 3 letters to basically convey no social reward. And as a control, as another condition, you would see the same information for somebody else. Yeah. And then this basically gives you a handle to investigate how this kind of social reward that is obviously very important for us is processed. And what they found, again, among other brain regions, they found that, again, this region here in the ventral striatum also responds to these social rewards. And if you just focus your attention here on the red bars, this would be the response to receiving money, monetary reward, and this would be the response to highly rewarding, very positive words in association with yourself. So this is, again, evidence that this human brain reward system, when we make decisions, also social decisions, also responds to social information, which again was also, those are new discoveries. I mean, this is only a couple of years old. This is something without the brain imaging technologies and combining this with psychological and economical thinking, we could not arrive at this new knowledge. And as a final example, this is recent work from my group in Berlin. We're basically building on Vasily's studies and other people's studies, and now again an example for the importance of considering individual differences. And the question we were asking is, we basically looked, and this is Dharmeshi, a postdoc in the lab, we tried to look into the question how we can explain Facebook use. So I guess Facebook is also used quite a bit here in Russia, I guess, right? And if you think about it, I mean, there are some heavy users that spend like most of their day on Facebook, and there's other people who don't use it at all or who just use it a little bit. And one idea we had is that if you think about what Facebook really does is, more often than not, people seem to be attracted to it because they receive feedback on their actions, right? You post something about what you did, a picture of what you did where, and you get feedback from other people. So the idea was that, well, maybe those guys who are using Facebook a lot are those who are also very responsive to social feedback in general. And therefore we used what I just showed you to test exactly that idea. So people were either doing a simple gambling task where they can receive monetary feedback, or they used a description task similar to the one I just described. So basically you would see a picture of yourself, and I should tell you, people come in twice, so they had a video interview, and we told them that an independent jury rated their appearance on that video and came up with a list of adjectives, and then we showed them again in the magnet that this is what people said about you. So but they basically said, okay, this is now about you, and people say you were honest. And then the question is, what kind of brain response does this lead to? This just illustrates the spread of Facebook intensity we had. So DAR made sure to have some people in there who use Facebook very little and some very intensive Facebook users. And now we can check whether there are brain responses that co-vary with that. And what we found here is, and this is basically just looking at brain regions that respond to the social feedback in green, I believe, and in blue, the brain regions that respond to just receiving monetary feedback. And this would be the overlap region of the two. So again, we find that there is this part of the brain reward system that responds both to monetary feedback and to social feedback. And what is really hard to see here, but what this shows is the correlation between the response of the individual brain and the corresponding Facebook use. So you find that those people, so if you just compare this person here with with a low response to the social reward, also has somewhat low Facebook use. And if you look up here, somebody who shows a huge response to the social feedback also uses Facebook quite a bit. Of course, this is just a correlation, right? So we explain some 20% of the variance in those signals. And of course, we also don't know which effect drives which, right? So maybe that using Facebook more makes you more receptive to social reward, but it could also be the other way around. But so this is something, again, providing an example how we can use these new techniques to gain some insight about something that we couldn't do before, and about the importance of considering individual differences. So I said all that already, and I hope I convinced you, at least to some degree, that this kind of new knowledge that comes from neuroeconomics, so from the combination of neuroscience, psychology, and economics, can inform the ways we make decisions, how it can at least provide first hints at how some of the strange behaviors that we observe, some of the strange decision patterns may be explained. And something I did not show you, but of course this is especially a hopeful direction of research also to look at mental disorders, right? So when we look at psychiatric patients, one of the distinguishing features often is that they make bad decisions. And so some people think that using the kinds of experiments that I just showed you may actually be very informative in that direction, that it may actually lead to new diagnostic measures. So it may not only be interesting in its own right, and it may not only be relevant for economics, but it may also be relevant in a broader context. And with that, I'd like to thank my collaborators here back in Berlin. Some of them now have moved on. And I'd also like to acknowledge the funding bodies that gave money so that we can do this kind of research. And I would like to thank you for your attention. And I was told by the organizers that you have this nice tradition of, at the end, actually now asking the audience to respond to a poll. And if I understand correctly, this involves you as well as the people listening to the lecture in the other hall. And somehow this, no, okay, I forgot this. Okay, this, let me, before we come to that question, let me make this advertisement. So now, if you think that neuroeconomics may actually be interesting, maybe for you or for somebody else you know, there is this, what's called the Society for Neuroeconomics. It combines people from neuroscience with economists. We will have the 10th annual conference here in Europe for the first time in late September 2013. So the first 9 conferences were held in the US. So this is the first time we're going to move to Europe. It's going to be in Lausanne, Switzerland, and with the idea of especially drawing younger people from all over Europe, Asia, also to the meeting. Right? It was clear that you couldn't go to the US, but I was told that there are actually somewhat cheap flights from Moscow to Lausanne. It's also an attractive region. It's going to be held at the Rolex Center, as you can see here, which is next to the lake, very fancy location. And we managed to get Vernon Smith as the keynote speaker. So some of you may know Vernon Smith received the Nobel Award also in 2002 for his work in behavioral economics. So that was the plug. If you Google Society for Neuroeconomics, you will find it, and you are very welcome to attend. So now let's come to the poll, to the tradition. I was told that the question is going to appear on the screen. Is that correct? The poll? Yeah? Yeah, right. So I'm going to read it out for you. No, so I hope it says that now that you've heard the talk, do you think that neuroscience, as in neuroeconomics, is going to be part of economics departments in the near future? And the 3 options, and this is not a trick, right? So I'd be really interested in the information to see what you think about this. And this should say something like, yes, of course, within the next 10 years, we will see this, that neuroscience is going to be part of econ departments. The second should say, well, maybe, but probably not within the next 10 years. And the third one is going to say, no, never, ever.
Ага. Маленькое замечание, что начало обратно.
When we start the final countdown, you will see 59 seconds on the screen, and then you start voting.
Oh, okay, that's... is that still counting? Yeah, still counting, okay. So those 6 people here, would you please come and talk to me afterwards? Okay. They got less now. Okay, let me threaten you again. Those 5 people, would you please come and talk to me afterwards? Oh, it's 6 again. I don't scare you. Okay.
Ну, голосование закончено.
The vote is over.
Out of the 66 people, there are 26 people who are really quite enthusiastic. That's great. That's great news. So hope to see you at the Neuroeconomics meeting, and also good to see that there are only 33 people who still think maybe. And it's I'm really glad to see only 5 people that are so skeptical. And of course we also need these guys, because if they don't exist, we get lazy. So we have to keep convincing you. So thanks everybody. I'm happy to take questions.
Коллеги, маленькое дополнение, пожалуйста. Можете даже представляться.
I didn't see much difference between option A and B when we are talking about a deadly disease. If I were a villager, any villager out of the 600 people, in A or B, it would mean the same to me. I would have a 30% probability that I would be saved, if I remember correctly, yeah? And 60% probability that I will not survive. Yeah. So I couldn't make my choice. You were teasing us. You were playing tricks on us.
Of course, obviously, right? I was basically
then I got it right.
You got it right. You got it perfectly right. So it was just portraying the same thing as either something sure and positive, where you would not be willing to take risks, although it's not a real risk, as you pointed out, or to put the same information in a negative frame. And the only point is that simply changing this from a more positive way of describing it to a more negative way of describing it changes your decision behavior. And this is maybe, if I may, the fact, this may actually not just be a toy example, right? You could think about this. This may actually have practical relevance. So especially if you think that older people are more prone to this kind of error. Yeah. So basically, what it leads to is, if you think people, let's say, especially in the US, I think it's a problem. So a lot of people have their pension funds, so their retirement savings, in risky investments, right? And so now financial consultants can use this information, right? So basically they know older people are more responsive to it. They can exploit that. And we think that these kinds of results may actually lead to practical consequences. In basically, we would have to tell elderly people that these effects exist. Yeah? And so basically by making people aware of this way, that their brain functions this way and leads to these kinds of errors, that they should consider this and thereby change their choice behavior. So it's actually one of my postdocs is very interested in that, whether this may actually lead to practical consequences. Yeah.
I believe it will be also very useful for marketing, for people who do advertisements. That's
for sure. Yeah.
Thank you.
Yeah, thank you.
Раз. Слышно? Russian, because it's...
Yeah, sure. I
my
think the
native
question
language.
gets translated. You may just do this. So we changed. You put off your headphones, I put mine on.
Okay, tell me please. Let me put a little bit of skepsis into our dialogue, and I'd like to ask you to explain a few things I misunderstood maybe. You took the classical psychological tests and tasks. You looked at the zones of the brain which are inhibited or fired, but this is description and just registering it. You did not derive any practical result from it. You can look up into the sky and say the sky is blue and the sun is yellow, and that's it. You just describe what you see. So the practical application, it's rather psychology in economics, not neurobiology, because you don't see any feedback, anything. I don't see any utility in your connecting neurons to dollars. How can we, using our neurons, make dollars or euros? That's my first question. And second question about economics. Economists, they never care about individual differences between people, because they always speak about a large number of people, and even each of them does something irrational. All in all, taken together, they produce something rational. So actually, they don't really care about the behavior of every particular person. Sorry.
Okay, perfectly fine. Good. So the first question is an important clarification. Of course, what economists try to come up with normative solutions, right? They try to, as you know, they try to tell you how you should make decisions. And you were right. What I showed you, the kind of research we do, is descriptive. Yes, absolutely. It's. I would even say it's purely descriptive, at least for now. Yeah, no argument there, not at all. I mean, we can't, and same goes for Kahneman, Tuwalski. We don't argue that this is normative, it's descriptive. Does it have any application? We don't know yet. Yeah, you're right. I mean, you're perfectly right. And the point is, this is a pretty young field, right? So if you look back, the first serious studies probably on value, they're maybe 10 years old now. So as I told you, we're going to have the 10th annual meeting of Neuroeconomics for a scientific cycle. This is very young. Does it lead to applications? Yes, to some degree. So the point is, And that's the experience from quite a few things. More often than not, what we describe using brain technology is not a lot different from what you could also say from just taking psychology and questionnaires. But it turns out that presenting things in terms of brain scans and also like biological mechanisms, people tend to listen more closely. So it tends to be more pervasive. I can give you one example Reed Montague did, and I don't think I'm not sure whether this would be. So here's a phenomenon we have in Western Europe and definitely in America. So we're now talking about medical doctors. So what do big pharmaceutical companies do to make a lot of money? They invite doctors, to go to the Bahamas for a nice weekend at a 5-star luxury hotel. They tell them about the new product, and the observation is, well, even smart MDs may tend to prescribe this new medication, although they should know better. And I'm an MD myself by training, and you would think you're a smart, rational person. I'm not prone to those biases, but you are. And so now, this was known all along, right? Psychologists told you this. But now what happens is, one of our colleagues, Reed Montague, did a study where he conducted a nice experiment, basically just telling the doctors, you're now visiting a gallery. So you're looking at pieces of art. Before the experiment, subjects were told, you receive a donation of whatever, $50 from a certain company, fantasy company, with a brand label. Now, during the experiment with the art pictures, they displayed logos of companies beneath the art pictures. It had nothing to do. They were just looking at art pictures. Sometimes it said, this is sponsored by Gazprom or whatever, by BMW. And now the question is, what did the brain responses of those participants show? What it showed is that people tended to value those images more that were associated with the brand logo that was from the company that gave them their donation. And this is something that even US Congress, they invited Reed Montague to tell them about these results. And now all of a sudden, the politicians over there think, okay, if this is, this happens in the brain, this is real data, now we have to take it seriously. I'm not making this up. This actually leads to changes in legislation. So that will be one example. And other examples are of the kind, that we can, clearly most of it is very basic research. It's only for people who care about the mechanism. And if you are just, if you're, let's say you're a marketing director, you may not care about the mechanisms. That's fine. But we need the very basic research about the mechanisms to then learn new things that may eventually lead to applications. The second question. I don't remember the second question. Can you give me a reminder, please, translator?
Just a second. The Economist.
The Economist. Sorry. Okay, this was that there. I also collaborate with economists quite a bit, and there are some of the kind you described, obviously, the macroeconomists who say exactly what you say. Well, but if you look at the whole society, it works this way. We don't have to look at the individual. But of course, there is this other breed, right? So there are behavioral economists, experimental economists who actually care about the individual behavior. And probably most of the things we do are for them rather than for the macroeconomists. Although there are actually attempts, if you think about, let's say, dramatic stock crisis. What do you call this? If a crash, exactly. Thanks. If there is a crash, so how do you explain a crash? And you would basically say, well, it's probably not relevant to look. Panic, exactly, panic. It's probably not relevant to look at the individual because, but the interesting thing is that there are some people who are now trying these kinds of approaches to predict a panic or shock in an experimental micro market. Yeah, this is like totally brand new stuff, and that seems to work. So you can actually use in an experimental market just a few subjects, yeah, and try to predict the dynamics of the market to some degree. So it's actually this kind of work is getting into the area where it may also be interesting for people who look at the macro level.
Следующий вопрос мой такой вот будет.
My next question. Years ago, the mankind has invented the nuclear bomb, and it got scared. Now there is another nuclear bomb ahead of us. It's in our brain. I already read some research on medical research impact on our brain, on some waves and how our brain changes under this impact. Is anything being done to somehow protect our freedom, protect us from marketing, advertising, and other impacts that may affect our brain and,
Okay, that's that's an important question. So the criticism we sometimes get is exactly that. So yeah, but this research only helps marketing people. Yeah, that's what quite a few people say is, why do we need to know this? It only helps people to even exploit the mistakes we make more. Of course, doing this kind of stuff, and there are actually also people doing this kind of research who try to put it to the market. Yeah, you will find neuromarketing firms. That's correct. I think there are maybe I think you don't have to be afraid because it doesn't work that well. Number one, yeah, I think there are very few examples where. The point is, it's to really do what I showed you. It's a very complicated process and it's expensive. So like to put one person in the magnet and to analyze other similar objects with similar objective value at different prices, and from that we would deduce whether something is an error. Not systematically. So the process model I showed you relies on the response times, and typically for those analyses we have relatively few errors. Yeah, so yes, enough for the model, but to look at the brain responses to them, we would need more error trials. So I wouldn't, I would not make a statement about that now. Should I choose or do you choose?
Здравствуйте.
Hello. I have read a lot of neuroeconomics. I've read about other trials and experiments. I know the background a bit more. So my question is, as far as I understand, a human is like a machine in a way, like a program or software, for instance, where there is some response to some motor stimuli or whatever. And like you say, if a person knows how somebody can influence him or her, he can protect himself against this influence, at least knows about this possibility. But the question is, if this happens nearly automatically, I mean our brain response, do you mean that if we understand these mechanisms, can we change the whole system? Can we change all we are born with? It seems unrealistic, I guess. Thank you.
That's a good question. That is a good question. Do I think we can... So did everybody hear this? Yeah, you understood the question because you speak Russian. Yes, so the idea is two ways. Number one, if you go by So to have a simple model behind this, and I think it's quite powerful, by Danny Kahneman. So according to that, and you probably know this, we have two systems. So one would be what you just described, spontaneous, rather emotional, affective response, more or less unconscious, something we cannot influence. And the other would be the system two, basically the more rational, deliberative thinking, very controlled way. And I think you can, and that's the argument really, once you're aware of the fact that there are certain decisions or behaviors that are ruled by this system one, so that tend to be maybe learned, very well learned, effective and fast. Fortunately, we as humans have this relatively well-developed system two. So you can train to basically use this cognitive control consciously to influence the stuff that maybe the system one thinks that lead to these errors. So this would basically be simply described strategies, right? So you would need to teach people to recognize situations where they may be prone to these errors and then use different strategies. And I think there are enough examples where that works. Yeah. So the thing is, can you develop rules where that works? And I would say, yes, it does. And the other would be, and that is probably much, much harder, to use training. Yeah. And the example would be, to use a simple example, let's say drug addicts. Yeah, so basically responses to if you're addicted to alcohol, if you do alcohol abuse, there are a lot of studies that show that your brain is responsive even to just seeing a bottle or a glass full of beer or something. Yeah, you get a crazy response, and the idea there is to actually use training procedures to unlearn this association, yeah. But you can already predict that if something like alcohol abuse has built up over years, you're probably not going to get you're not going to get rid of that within an hour. It probably requires very hard training, but this is the kind of thing that starts to emerge from studies. So where you basically try to directly impact on the reward system and to change these learned behaviors. So it's not. If you ask the fundamental question, is there any way to impact it? I would say yes, indeed, by these two routes.
А вы вот лично...
And have you yourself tried to change anything, like you explained? It's one thing training others. Have you tried to train yourself in practice? Have you?
Yeah, but I'm not going to tell you. No, the serious answer. Yeah, sure. I mean, yes, sure. I try to. I mean, I haven't. I'm not an alcohol addict, so I'm not. I haven't tried that one. But I actually try to. Of course, I sometimes try to use what we gain to look at that. Yes, of course. Yeah. I don't have a good example, but. Yeah. So I think the framing one is the most obvious. Yeah, to look out if you get things to make a decision upon, and that actually happens quite often as with the kind of things I do. You pay attention to. Oh, wait a second. Is this just a very positive way to put things? And of course, I tend to use it for my own purposes. Yeah, I mean, I try to. Bend the information so it's positive, but also I don't want to be prone to the same mistake. Yeah, I don't know if that's it. There were some people who were like holding out very. Yeah, you.
First of all, thank you very much for your very interesting lecture. Thank you. And my first question is about emotional and rational ways of deciding things.
Mm-hmm.
When and where in the brain is this decision taken, whether to use emotional or rational way of reaction? And well, a second question is a bit more specific about jump diffusion model. As far as I understood, the input to jump diffusion model is taken from two different areas of brain, right? How is it possible? I mean, the one point in the brain is responsible for negative response, and the second one for positive. How does it work?
Okay, so the first one, the first question about effective versus rational is actually more difficult than it sounds. And I know, I mean, if like the easy way would be to say, yes, of course, we know there is this emotional brain, the evolutionarily old structures like the amygdala and some circuits, and then there's this other circuit, and this is only in the prefrontal cortex. And that's kind of the cartoon version that you find. And there's, as usual with those cartoons, there's some truth to it. Of course, there are some brain systems that you also find in much lower species, that are more responsive or more responsible for the simple, effective kind of processes. And it is certainly also true that we're the one species that has developed this relatively gigantic cerebral cortex that many other species don't have. So it makes a lot of sense to think that the more rational things have more to do with like prefrontal cortex regions that are more developed in our species than in other species. But that's true as a cartoon model. The reality is much more complicated. So, for instance, the amygdala I briefly mentioned, you will find it in some popular books as the emotion center of the brain. If you look into that in detail, turns out the amygdala is pretty much involved in almost everything. Like it's the big information hub of the brain that's connected to all other systems. So it's more complicated than that. Which brings me to your second question. How is it possible that you have this information that is represented in different places in the brain and gets integrated? Well, that's the point of the story. We know that there is, of course, parallel processing in the brain, but also to some degree hierarchical processing. So you do have higher level structures that listen to what lower level structures do. So and in this case, the argument is that you have higher level regions like parietal cortex or prefrontal cortex, that actually get the information from the lower level regions. So that is neurobiologically entirely plausible. So that information is read out from different regions and then combined. Yeah, the gentleman with the blue sweater was very patient.
Sorry, коллеги. Мы очень интересно проводим время.
We are spending a real good time, but the time is limited. I guess we can have two more questions because we've got 10 to 12 minutes till the end of our lecture, so please keep to the agenda. I'd like to ask you the following. What about the brain zones in left-handers and right-handers in your experiments? Have you seen any difference?
Yeah, that is a very interesting question, but unfortunately has a very simple answer. In 95% of those experiments, we only use right-handers. Does he get a translation? Did you translate for him? No, you do? Okay. So the thing is, so we know that some things are different in left-handers. So, like, I'm a left-hander myself, so I know what I'm talking about. The thing is, for many brain processes, we know that things are lateralized. So, sometimes one, like language would be a prime example. One hemisphere has more to do with it than the other, and we know that this tends to be different in left-handers. And so, since we know that, we try to exclude that factor. So we basically, in 95% of those studies, we only look at right-handers. So the honest answer is we don't know. Hey, this guy with the blue sweater here, he was like waiting for an hour. No, we should let him. Yeah. There you go.
Thank you. First of all, thank you so much for this brilliant introduction to neuroeconomics, and I have a very simple question about the methods that I use. Is fMRI the only method you employ in neuroeconomics, or do you use some other methods from neurosciences? Because, as we all know, fMRI has a number of problems because it is based on correlations and cannot reveal causal relationships and so on. And yeah, you mentioned that the possible solution is to study psychiatric patients and maybe other methods. Thank you.
Yeah, thank you for that question. Excellent and very well justified point. There is, of course, what I showed, brain imaging, so fMRI is only one technique with admittedly a lot of problems, and there are other techniques. So there are groups around the world that use EEG, so electroencephalography. For instance, our friends here from St. Petersburg and also here in Russia are using these methods, EEG or also MEG. So I just heard there's a new MEG facility not too far away from here. So magnetoencephalography, where you use the fact that the subtle changes in electrical activity also lead to very tiny changes in the magnetic field. And turns out you can detect that. So that's two other methods. There are, of course, stimulation techniques that you could use, right? So you could use what's called transcranial magnetic stimulation, and that gets more causal. So you can apply changes in magnetic fields over the cortex, which leads to changes in neural activity, and then also leads to changes in decision behavior. There are very few studies, as you may know, where you can try to stimulate the prefrontal cortex, and you can show that people's behavior in economic games, for instance, changes. So that would be another one. There's also transcranial current direct stimulation, so kind of electrical stimulation that's being used. So yeah, there's a whole battery, of course, of let's say neurotechniques that you can use. You can also think about pharmacological approaches. Yeah, so we know that certain drugs that people would take, let's say for Parkinson's disease, like L-Dopa, also can affect, especially the reward system, obviously. Right, so this also gets more causal. So you can think about dopamine medication. You can also think about like antidepressants with effects on the serotonin system, and all of that. Yes, of course, it's part of that bigger research program. Yeah, so it's of course not only about brain imaging, but many other techniques that we may use.
Здравствуйте, изучаете ли вы?
Thank you. Do you study intuition, and is intuition somehow related to spontaneity? Once again, do you study intuition phenomenon, and is intuition somehow related to spontaneity or spontaneous nature of things?
So the simple answer is no, I don't study intuition. Of course, it's very interesting. Yeah. So what you're probably hinting at is there's of course quite a long tradition in a field what's called bounded rationality, and researchers that have identified a set of relatively simple rules that are called heuristics that you may apply to decision making. So if you would talk to some of the representatives of that field, they would argue that what I showed to you, like, you know, that decision makers really weigh the expected value and the risk is nonsense, right? Yeah, because you usually only use these heuristics to arrive at a decision, which boils down to just listening to your feelings. So these famous gut responses, yeah, the gut feeling. I think that's. I should probably say I simply it's these kinds of heuristics, or as you called it, intuition. It's very hard to study that using our kinds of methods. So the problem with it's a very methodological answer. I'm sorry. Our method relies on having the ability to repeat trials over and over. Yeah? So the cases where I gave you with the gambles, in our case, people would do this. I don't know, 200 times. And with intuition, it's pretty difficult to design an experiment where people would repeatedly make intuitive judgments. And then also how to tie that back to the neurobiology is unclear. There are some people who are looking at that for sure, yeah. But I can't really tell you a lot about that. I'm sorry.
Здравствуйте. Лучше.
Так, всегда есть какой-то последний вопрос. Thank you very much for your lecture. There were so many interesting answers, but even more interesting questions. You spoke a lot about the neuro parts of everything because we are studying the brain, trying to understand how it works. But I didn't hear too much of economics in what you were talking about. For instance, I didn't quite understand why should I study the brain as a neurobiologist if market experts, advertising experts, just commercial guys, they know it all for many years. They know it based on their practice, based on their experience. Do we economists really need such a study model based on studying our brain? Don't you think that neuroscience is just a brand to get sponsors for a large number of new studies, or what?
That's a nice provocative question. Well, and the answer is it depends what you're interested in, right? So that's what I'm saying. I think that's an important point. I don't think you need neuroscience to answer. You don't need neuroscience for all of the questions you may have. Yeah. So there is a selected subset of questions where neuroscience may be informative. It happens more often than not that students would approach me and tell me, okay, shouldn't we do this? Nobody has done that, and I tell them, look, why do you want to do this? Just do a simple behavioral experiment, and you have the answer. Yeah. So it's really I'm not arguing that only having the brain data will give you the reality. So this neurorealism, I don't adhere to that. Yeah. I think there is a certain set of questions, and probably the things I hinted at, where neuroscience can actually inform economic theory. And the point is, if you're interested in that, yeah, there may be, okay, like the IIRA, so the violations of the independence of choices that I mentioned, right? So by adding the third irrelevant choice to the choice set, is something that, as far as I know, economic theory is pretty silent about. Yeah, I mean, there are some explanations about it, and it's clear it doesn't fit with the standard model, but the jury is still out on the reasons for this. And we will have to see, but I think there is some hope that this is some area where the neuroscience can add to it. There's another layer. And this is probably more fundamental. So the things, you're an economist, right? Is that what you say? Yeah. Yeah, a little bit. Okay. So then, then you know that it's quite difficult to actually get a scalable measurement of utility, right? So it's always ordinal, right? All you can say is, yeah, okay, maybe if you compare A to B, you find more utility in getting A than in B. Exactly, and the argument is actually there is, we are very cautious. There is some hope, also because you can actually also measure it in animals. Yeah, you can record from dopamine neurons, you get a quantitative measure. And the idea put forward by some people is that you may actually take this measure and plug it into your, let's say, random utility models. Yeah, so it may be something like the common currency that people were looking for. As I say, I mean, this idea is just, it's a pretty fresh idea. It's just an idea, but there is some evidence to prove it. But just to say it again, you don't need neuroimaging for everything. No, by all means not. And of course, there are many economic questions where this is irrelevant. Yeah, like of course, for macroeconomics in its own right, you don't need neuroimaging. No. Yeah.
Dear Mr. Heekeren, dear guests, time went by so quickly. I'm not sure everybody got answers to their questions, but we spoke about decision making. Thank you so much for coming, for telling us about the mechanisms, and probably influenced somebody here, probably something